now talk about mode shift for lateral directional case. It is again the approach is same. Here you have to use the stability equation that was SU1. Let me write this y beta into beta of S minus S yp plus g cos theta 1 into phi of S plus S u1 minus yr to psi of S. This is equal to 0. And then minus L beta into beta of S plus S square minus LPS into phi of S minus S square A1 plus SLR psi of S equal to 0. Similarly, minus N beta into beta of S minus S square B1 plus NPS phi of S plus S square minus SNR into psi of S equal to 0. So these are free response. Remember the stability matrix. This into beta, this into phi, this into psi, like that it is going. When you say phi, please remember phi dot equal to P has been modeled. So S of phi of S is P of S. So wherever P of S is there, you can replace by S phi of S. That's why you could see Yp into P. For that P, the S phi of S has come. Right? Now once I do this, I do it for a free response, then I can write, again, since I'm looking for phi of S by beta of S and psi of S by beta of S, you know what I have to do? I have to divide by beta of S, and then I get equation of the form minus SYP plus G cos theta 1 into phi of S by beta of S. It must be very boring. It's indeed boring because it is too simple. You have to take a pen and pencil and follow the instruction. Of course, nowadays you are all high-tech people. You go to the MATLAB and do it. There is a danger using MATLAB. You may lose the insight because the MATLAB, the moment it understands you have not understood the dynamics, it will fool you. Please be cautious. Similarly, I have S square minus LPS phi of S by beta of S minus S square A1 plus SLR into psi of S by beta of S equal to L beta. This little arrangement, and then minus S square B1 plus NPS phi of S by beta of S plus S square minus SNR psi of S beta of S equal to N beta. So what is our aim? Our aim is to find this ratios in frequency domain. These are three algebraic equations, right? So easily you can find out the expression for phi of S by beta of S or psi of S by beta of S. And if we do a little bit of handling algebraic equations, simultaneous equations, you know, by method of substitution, method of subtraction, the Cramer rule, whatever it is, you can find out phi of S by beta of S as A1S plus B1 by S A square plus B of S plus C, and psi of s by beta of s equal to a2s plus b2 by s a square plus bs plus c, where for completion I am writing a is equal to 1 minus a1 b1. Remember a1 b1 are nothing but ratio of moment of inertia which we defined earlier, b equal to minus nr minus lp minus b1 lr minus npa1, c equal to lp nr minus lr np. Similarly, have a1 equal to l beta plus a1 n beta, b1 equal to n beta lr minus l beta nr, and then a2 equal to n beta plus b1 l beta, and b2 equal to l beta np minus lp n beta, like this. Okay? So what is the message? Message is very simple, that if I want to find out mode shape phi of s by beta of s, that is, I want to see relative magnitude between phi and beta, that is, phi is this, and whether it is developing beta or not on that mode, if at all, what is the magnitude, relative magnitude, and what is their phase difference. What I need to do? I need to put the value of s. A, B, all these constants are known by the, once I know those dimensional derivatives and moment of inertia, etc., etc. Now the question is, for lateral directional case, see you have again the equation of the form as4 plus bs cube plus cs square plus ds plus e equal to 0. So for lateral directional case, you have lambda 1 some value, lambda 2 some value, lambda 3, 4 some complex conjugate. Okay? So this is Dutch roll. So if you want to know about phi of s by beta of s, if you are looking for a spiral, put the value of s here from the spiral root, whatever you have got. Similarly for here, so you will know the ratios. If you want for Dutch roll, put that value s here and get these ratios. Once you know the ratios in as a part of complex number, you now know how to find the magnitude and the phase difference, right? That is as simple as that, not a big deal. Let us say for a particular airplane, the value of A, which has come, let's say around 1, B is 0.541, then C is 0.0452, then A1 is minus 4.1, B1 is minus 0.027, A2 is 2.59, and B2 is 1.130. Let us say how these have been computed. You know the expression of A, B, C. And for the airplane, you know what is A1, B1, you know what is LP, LR. For a given airplane, let's say example airplane, once I put these values, I get A, B, C, A1, B1, A2, B2. These are the value for an example airplane. For an example airplane or aircraft, and we are talking about lateral directional case. That is important, right? Because this values of an expression of A1, B1, A2, B2, etc., all whatever I have computed here pertaining to lateral directional case, the expressions are like this. Correct? Once we do that, let's say we try to find mode shape for spiral mode. That is our next mechanical challenge. We are trying to find out mode shape for spiral mode for the example airplane. And if you recall, for spiral mode, it was a real root, so S was a real number, the complex part was 0, and the value was minus 0.00101. Okay? So if I want to find out phi of S by beta of S, I have to put here phi of S by beta of S. Of course, we are talking in terms of ratio of two complex number. So I'll put value of A1. So A1, what is A1? Is minus roughly 4.1 into S. So that is minus 0.00101, right, plus B1. B1 is how much? B1 is minus 0.2073 minus 0.0273 divided by, again, S, that is minus 0.00101 S, then again A square. So you can put A value is how much? What is A value? What is A? A is 1. So S square, this is minus 0.00101 square, right? Plus B of S. B value is how much? B you could see here, 0.541 into S is again 0.00101, right? Then plus C, C is how much? Check here, what is the value of C? 0.0452, and this, if you do that, I may commit some mistake in putting the values, don't blame me. Simple thing, A1, B1, all these values you know, S you know for spiral mode, which we have got from the exact equation of the same airplane, is minus 0.00101. You have to simply put those values here, and let's say this comes to ratio of minus 0.0231 by minus 0.00451 ratio. Okay, I draw the magnitude, I get 512. For psi of A and beta of A, similar thing if I do, I get numerator 1.127, denominator is this, and this is 24,989. What are the interpretation you are having from this? That is I am asking. That is the beauty of the mode shift. First of all, you see phi of S and beta of S, the numerator, denominator, they are all the same sign. Phi is tan, arc tan if you find. There are no imaginary parts, so the phase difference is 0. However, you could understand that magnitude of beta is very, very small. That means phi is more dominating for lateral, phi is more dominating for spiral mode. You could see bank and start side slipping, this further bank, so this goes. So this clearly tells you for a spiral mode, I am more bothered about the bank angle, right? And that is the information I get from this, looking at this numerator, denominator. Two things I understand, if they are in phase, so whenever phi is changing, same time beta is also in the same direction changing. However, the contribution of beta is very, very small compared to phi. So for a controller, you see what a wonderful information for him. He knows now what aircraft control to be used, or which one has to be corrected first, right? There are many such decisions one has to take. If you see psi of S and beta of S, again you see numerator here, denominator here. The magnitude is 24,989, this ratio. That means really in terms of psi, beta is again very, very small in comparison. But one thing you remember, the psi and beta, because there is minus sign here, so they are phase of 180 degree, right? 180 degree phase difference, right? So where it was, they were in phase, and psi and beta phase are out of phase. And you know that psi is this, then beta becomes negative, you know. Psi equal to minus beta, if I am not talking about a coordinated turn type. So which is also giving you a correct information. What interestingly important for you is that beta participation is very, very negligible in this spiral dynamics. So you can design a controller and give it priority, and which variable you have to give priority, this will help, right? So we have given example of spiral mode. Now we talk about roll mode. What do you have to do? Same equations. Here S should correspond to roll mode, right? From that exact equation. And you know the roots already I have given you. And if I write phi of S by beta of S, I use that expression, put the values. Now I should put S corresponding to roll mode. And if you see that example, if I recall, the value was 0.507, right? That was the value of S or the root. If I put those values in those expressions, then I get phi of S, and this as 2.075 by 0.0141. This is equal to 147, roughly, approximately. And here, psi of S by beta of S, I get as minus 0.183 by 0.0141. The magnitude will be 12.98. Very simple. I have to just put roll mode S value in this expression, nothing more. A1, A2, all are we are knowing. So again, here you could see that phi of S, phi and beta are in phase. Okay, and again, beta is less compared to beta domination is less compared to phi, which is roll mode, right? Highly damped. And for psi and beta, you find they are in out of phase. The phase angle is 180 degree because of this minus sign here, right? So that is, as a designer, what should I infer is the roll mode is predominantly dictated by phi, and that we know. Okay. Now we will try to get more shape for or understanding for Dutch roll case, and let us see what happens. When you are trying to find out for Dutch roll mode phi of S by beta of S, my job is very mechanical. I know this is the expression. I know A1, B1, all those values. What I have to do, see from the exact equation what was the value for S, and one of the root for complex conjugate is this. So this I substitute in those equations, and phi of S by beta of S I get in this form 0.213 ratio of two complex number into 6.70 divided by minus 0.961 minus j 4.240. This is the phi of S by beta of S in terms of ratio of two complex number. And now you know how to find magnitude. So phi of S by beta of S, so magnitude is concerned, that will be equal to under root of, you know by now the expression, it will be 44.89 by 0.92 plus 17.98, and which is equal to under root of this, which will be equal to 1.54. That you know now, no? Omega n square, numerator square, denominator square, already you have given that expression. This is the magnitude. Similarly, if we try to find out psi of S by beta of S, you will find this ratio will come as minus 0.980 plus j 4.19 divided by minus 0.961 minus j 4.240, roughly this. And you can easily find out the magnitude. This magnitude will come as the magnitude of psi of S by beta of S. You know how to find out. This will come as around 0.99. Note down this. One is 1.54, one is 0.99. But one thing you should understand, when I try to find out their phase difference between phi and beta and psi and beta, now also we are ready with the formula. We have already written this earlier. So if you find out the phase phi of s by beta of s, this will be arc tan minus 6.70. I'm just writing it so that you can follow it. In fact, you should not see even this. You should be able to find out yourself. Arc tan minus 4.24 divided by 0.960. So this will give you roughly minus 165.4 degree. Similar exercise if we do for psi of s by beta of s, you will get this to be around minus 154.07 degree. Okay, but then how do I interpret this? Which one should I give? Which one should I give more importance? As long as we understand the phase difference between phi and beta for a Dutch roll, that means when phi is becoming positive, beta is not becoming positive at the same time. That is very important. There is a phase difference of 165.4 degree. Similarly, stories with psi and beta, right? That's why I was telling it is not this, it is this and this. If it was 180 degree, then when this man was doing like this, airplane should have gone like this. Then they are out of phase 180. One is going like this positive, another is going like this. So swaying motion in this direction, yawing motion in this direction. That is 180 degree phase psi and beta. But it is not happening. Again, we come back to this phi of s and beta of s. You could see phase difference is 165 degree, and between psi and beta is 154. So you know relatively how psi and beta are functioning in terms of their phase differences. They are definitely not in phase, they are out of phase, right? Almost 180 degree out of phase, opposite, right? This is one. And second thing, you understand that for me, this is important, phi and beta, this transfer function or this mode shape, typically for handling quality requirements. From handling quality requirement, we try to have this ratio as low as possible to validate or to justify or to get a scale for acceptance for Dutch roll excitation. That is extremely important. If the airplane is banking and side slip, this ratio is very, very high, then you can understand Dutch roll oscillation acceptance will not be approved. It should be as low as possible, right? So this, in a nutshell, you could see very simplistic approach, right? We could get so many information out of these mode shapes. You can do a lot as long as you work in a linear system using transfer function approach. But I must also caution you today with highly maneuverable airplane and using time domain, is working in time domain, in state space modeling, nonlinear aerodynamics. This may not look very relevant apparently, but let me tell you, before you design anything big, you need to understand this. That gives you solid foundation, and bigger things are just addition to this. Basic foundation is here. You need to solidify your understanding here before you make the next jump. Don't go for a fashion, nonlinear aerodynamics, nonlinear controller. First you understand this. Get the right fragrance and smell of this approach. Understand, enjoy the sweat of this required to put in this approach. Then you'll find you'll get the real fragrance, and you will be ready for a controller designer. I'm sure you will do nice. Nowadays, our startup companies are doing excellent in designing controls and all. And a very good sign, very good contribution coming from youth. I am sure you will be able to add value to that further.